Good morning. So, yeah, we're going to do a water testing update. So basically just looking at what you should be doing about water testing today to comply with today's regulations. And then a little bit about some additional tests that you might consider doing in today's environment where it's becoming more difficult to look after pool water. And then we're going to do a little bit about, this is my 20th year at SPATEX, so my 20th year of doing talks. So we're going to do a little bit of reminiscing on 20 years. I'm not going to do all 20 talks again, don't worry, we'll be here till midnight. So just looking back at some of the highlights of the last 20 years. So I always do this when I do talk about water testing, we have to think about why we test the water. And we do it to make sure it's safe for people, it's very important. Make sure it's comfortable, and people know are comfortable when they get in there. We make sure there's sufficient treatment, but not too much. That's very important. There's no point adding more than you need because it doesn't actually do any better than having just the right amount. We have to look after the pool and the plant. As I often say when I do full blown training courses, what is a swimming pool? What is a hot tub? It's a container of water. And you put things in it like pumps and lights and filters, but the only thing that comes into contact with every part of the pool is the water. And if it's not right, it can actually do an awful lot of damage. You can control the costs of the chemicals used because chemicals are quite expensive nowadays and testing is actually relatively low cost, so you can control the cost of the chemicals. And you have to be compliant with guidelines. And as we say, if you don't know what's in there, how can you test? If we look at the Institute of Swimming Pool Engineers, as I'm talking on their behalf, they actually have a few more reasons why you would test water, like controlling the smell and taste, etc. But they're basically the same. And as I said, if you don't know what's in there, how can you treat it? And when it comes to compliance, there are various things depending on what your pool is. So if it's a domestic pool, you basically should have your own operating procedures, a maintenance manual. If it's a commercial pool, you should have a pool standard operating procedure or PSOP. You should be following QTAG, especially their code of practice, their pool water book, which is in the process of being rewritten, so don't buy one at the moment because there'll be a new one out next year. And there are various technical notes that they issue throughout the years that update you on what you should be doing. And if it's obviously the HSG guidelines as well, 179 for swimming pools. And if you're doing a hot tub, anyone got a hot tub in a commercial setting? Oh, well, you have. Do you know about HSG 282? Yes, you should definitely get a copy of it and make sure you're doing what it says because it's a lot stricter than any pool guidelines. And if you belong to some associations like the K9 ones, etc., they'll have their own guidelines as well. So good practice, and this is as recommended by us as a company rather than any guidelines. You should always take the sample from the pool and test straight away. The reason you test from the pool is you need to know what's happening where the swimmers are. So you would only take a sample from pipe work if you were calibrating a controller. Generally you wouldn't take samples from pipe works because people don't tend to swim in the pipes. And as I say, if they are, you've got bigger problems than worry about testing water. So you take it from the main body of the water. Everything should be clean, dry, rinsed. That's very, very important. Dirty equipment will give incorrect results. Should use a suitable location and don't cut corners. So a suitable location is, if you're using a photometer, you really should use that away from the pool side because photometers use glass cells. They will break if you drop them, and glass and swimming pools don't mix. If you're using a comparator, anyone still use comparators? No, if you are using a comparator, you should have a good light source, preferably daylight. So that's what I mean by a good location. And don't cut corners. Basically means if the test says wait 2 minutes, we do mean wait 2 minutes. We don't mean go for a coffee break and come back 20 minutes later, or wait 30 seconds and push the button. It means 2 minutes. Unfortunately, now most instruments have countdown timers, so you can't override them. So yeah. Suitable equipment. So if you're a commercial, it should be a a photometer or glass-based comparator, not test strips, but if it's domestic, you can use test strips. Never handle tablets. They're not dangerous, they won't hurt you, but you will contaminate them. Always follow the instructions and ensure you have the people trained. And use the motto, read, record, react, and when you're finished, clean out cells immediately. So read the results, record the results, and someone should know what to do with them. They shouldn't just be left. So PewTag testing guidelines is that operations should be trained. You should use professional systems. You should make sure the range is correct for your application. You should use a recognised test chemistry, and the only recognised test chemistry for chlorine at the moment is DPD, so it should be DPD based. Everything should be scrupulously clean, so they're really into cleanliness. They should be checked regularly to make sure they're still within specifications, so weekly if possible, and then most systems now have kits that you can check them with to make sure they're still working. And they should use the correct tablets. And nowadays, tablets tend to be not interchangeable. So if you're using our systems, you should be using our tablets. If you're using someone else's system, you really should be using their tablets. 20 odd years ago, there'd probably been very little difference, but over since the turn of the century, tablets have changed an awful lot, so they're not really interchangeable anymore. Testing frequency depends on what you've got. If you've got running a domestic pool, test it as often as necessary to make sure it is safe for the application that you're using. So if you've got a domestic pool that's only got 5 or 6 swimmers a week, maybe once a day is enough. It's up to you to do your own risk assessment and decide. If it's a commercial pool, you should always test chlorine and pH every 2 hours, or at least 3 times a day with an auto-dosing system. But realistically, you should be doing it every 2 hours with an auto-dosing system or not. It's the safest way to do it. Chlorine and pH always go together. You should be doing the other tests weekly because, in theory, you should be doing what they call a balanced water test, which I'll cover briefly in a second. And hot tubs, commercial hot tubs again, should be follow HSG 282 guidelines, which actually says they should be tested at least twice a day. Doesn't matter where they are, even if it's a one hot tub in an Airbnb, it should be tested twice a day. Whether that happens or not, who knows? But and it's all to do with the reducing the risk of Legionella. I shouldn't mention Legionella, but hot tubs are the 3rd biggest cause of Legionella in the UK now, following cooling towers and air conditioning systems. So it is a bit of a risk. But I'll stop there. There's too many hot tub suppliers around here for me to keep going on about that. So that's the frequency of testing. And what should you test for? This has always been the main test that people would do. Disinfectant, 99% of the time it will be chlorine. You will have your own operating procedures. You will set your own levels depending on use and risk, but you should be following the PewTag guidelines. Total or combined chlorines, the guidance now is to be ideally 0 on combined chlorines. Very difficult to get. Still the guideline is should be less than half the free for the combined chlorines. pH has changed recently in that during COVID, the pH range got pushed down because it's found that the more efficient the chlorine, the quicker the COVID virus was deactivated, and it was decided that the ideal was to start at 7. That's now been set in stone. So 7 to 7.6 is the sort of the range, but 7 to 7.2 is now considered the ideal. Alkalinity, hardness have not really changed. And cyanuric acid is a stabilizer that's added to some chlorines. If you get too much, it basically locks the chlorine in. You'll read different articles. It says chlorine lock starts at 100, sometimes 200. The guidance is keep it below 100. Our guidance would be to have it as low as possible to make it work, but not have too much. So 30 is a good reading, for instance. And TDS is the dissolved solids. Again, hasn't really changed. PewTag is often releasing technical notes, and recent updates have been TN2, which is the technical note on fecal contamination, a good read if you want to get it out, has been changed to bring the pH into line with the guidance of 7 to 7.2. The ice baths are becoming more popular, and they should be treated in exactly the same way as a swimming pool or a hot tub and be tested in exactly the same way as well. All because the water's cold doesn't mean there's no bacteria in it. It just means they're a little bit more dormant, but give them something nice and warm to go into and they'll suddenly come alive. So they should be tested exactly the same way with exactly the same levels as any other swimming pool. And others that you might be interested in are 53 is microbiology testing, 60 explains free active chlorine, so it's the amount of free chlorine against pH. It varies as pH changes, and TN61 explains combined chlorine, so they're good to have as well. So just look at chlorine. You have to use DPD-based method, whether it's a test strip or a tablet or anything like that. It should be a DPD-based method. Free chlorine is the good stuff that you want. It's available to use. The total is the free plus the combined. It's the combined is the stuff that you don't want. The combined is the chlorine that's been used with something that's formed a chloramine, and that's the stuff that causes irritation and chlorine smell, etc. So I often say here, if you walk into a swimming pool and you get a strong chlorine smell, it's actually not a good sign, it's a bad sign. They've got too much combined chlorine. I said the ideal level should be 0, but the ratio of 2 to 1 is still widely accepted. It's 2 free to every 1 combined. And if you've ever sat there at a night thinking, what does DPD stand for? It stands for N,N-diethylpethylene diamine, which is why we call it DPD, because no one can actually say that without hesitating. And you'll find it's used across the world now. pH is how alkaline the water is. Its range is 0 to 14. Neutral is 7. And it's really measured for 2 reasons. One is for comfort, but the more important reason is chlorine efficiency against pH is very, very important. The little graph shows you, this is chlorine efficiency, and at a pH of 5, chlorine is very efficient, but a pH of 5 is 100 times more acidic than a pH of 7, so you can't have people swimming in that sort of acidic water. Because 7 is neutral, and we as animals tend to like neutral things, our skin is almost neutral, we have to swim in neutral water. So it's very important to control the water as close to 7 as you can to get as maximum chlorine efficiency against comfort. And as you can see, as the pH goes up, once you get to a pH of around about 8, chlorine becomes totally ineffective. So it's very important to control pH. Total dissolved solids are the dissolved solids in the water. Every water has dissolved solids in it. Drinking water or potable water that most pools are filled with has a level of 400 to 600, depending where you are in the country. We then add to the dissolved solids by putting chemicals in, by putting people in. They themselves bring in the form of dissolved solids. And if you didn't dilute it down by doing backwashing, it would build up and up and up. You'd end up with a salty taste. It would affect the chlorine efficiency, so it has to be controlled and measured weekly. And it's controlled by backwashing. You can't filter it out, it's dissolved. So. And cyanuric acid, I did mention, it's in stabilised chlorines. You can add it separately. It protects the chlorine from being burnt off by direct sunlight. So, but it's being used. Stabilised chlorines are being used in indoor pools. They don't need to be, but does mean then cyanuric acid's being added to indoor pools. And it causes what they call chlorine lock. It locks the chlorine back in, but any cyanuric acid in your water will slow down the efficiency of chlorine. So you just have to keep measuring it. So if you're not sure if you're using a stabilised chlorine, it's best to check. And balanced water is another test, also known as the Langelier index. It tells if your water is corrosive or scale forming. You need to have 5 measurements, as it says there. They're then put into a formula, which gives you either a plus figure, a minus figure, or a 0. And plus is scale forming, minus is corrosive, and 0 means it's balanced. And the PUTAG guidance now is to go for balanced water. So to go for a zero figure. Ideally, you want a zero or slightly positive figure, because having slightly scale-forming water is better than having corrosive water, so you want to avoid negative figures. And it is important. This is an actual, this actually happened in a pool. The green figures on the left-hand side for their balanced water are the figures before the change in the pH regulations. So these were their figures during prior to COVID, where the ideal was 7.2 to 7.4 for pH. So they were happily running at 7.3. During COVID, it was suggested to bring the pH down. So they did bring the pH down to 7, but they didn't adjust any other parameters. So as you can see, their water went from being scale-forming to slightly corrosive, and they started losing, it was a tiled pools, tiles. PUTAG then changed the guidance to say if you are changing the pH, check your balanced water, because it wasn't actually in part of the guidance. But it can make a big difference if you don't actually check the balanced water. So how are things changing? As I said, pools are becoming more challenging. We now have lots of equipment in pools, UV systems, pumps, floor lifts, all sorts of things. And they're becoming more challenging. And as we become more civilized, as it were, more developed, we want to test for more things, and there's more things adding problems. In November, I was asked to speak at the PUTAG conference, and I did this in partnership with Palin Test when we talked about the future of water. And there we are doing the talk. We did discuss testing systems, how they may change. We did discuss connectivity and data handling and compliance, because they're all changing as well. But we did more discuss about the parameters that people might want to test for and how they could be changing. Chlorine and pH will remain kings. They'll always be tested. They always need to be tested. But these are some of the other tests that will become more and more important and should be considered to be tested. So turbidity is one of them. It's how cloudy the water is. Now, I think we'd all agree a cloudy water is not a good water, a cloudy pool is not a safe pool, but I don't know if does anyone actually ever measure the turbidity of their pool? One people do. So PUTAG have got a guidance, which is 0.5 NTU, which is very, very clean water. That is the same as drinking water. So in the old days, it would be, can you see a coin at the bottom of the deep end? That would be your result. Now, and it got effective, can you see if it's heads or tails? You really should be measuring your turbidity. But PUTAG has a guidance, and it can indicate poor water conditions, poor chemistry, etc. And that picture shows a pool with a turbidity of 0.9 NTU. So not far off 0.5, but if you had underwater safety cameras or drowning detection devices, they wouldn't be able to see across the pool. That's why it's important. And they would have been set up against the turbidity. So that's why you should consider measuring it. I won't say too much more, because my colleague is doing a talk tomorrow morning on turbidity in swimming pools. So if you want to know more about turbidity, come along tomorrow morning, and Matt will do a whole 20 minutes on turbidity. Sulfates, they enter the water through chemicals. More and more of it's getting into the mains water. Why are we worried about them? They cause sulfate attack. They'll corrode cement, grout, metal components, and they'll degrade plastics. So you don't want sulfates in the water, basically. They contribute to dissolved solids. They impact the water balance and the chemistry. And discharging sulfates can harm the aquatic system as well. So you have to be very careful with sulfate levels. Phosphates enter the plains from mains water. 99% of mains water in the UK has phosphates in it, because water companies love adding phosphates to water, so it coats all the lead pipes that we have underground, so we don't get lead poisoning. That's one of the things phosphate's good at. But obviously phosphates in swimming pools don't mix very well, because they cause algal blooms, even in indoor pools. If they've got sunshine and you get algae, you'll get algal blooms. The algal growth, cloudy water, green water, increased chlorine demand, filtration, strain, etc. And it's discharging lots of phosphate, contributes to eutrophication, basically nutrient-rich water going into the river streams, causing issues there as well. So you don't want phosphates, basically. And aluminium, at the talk, at the conference, there was lots of talk about flocculation and the effect on alkalinity levels. Most people use PAC. Does everyone use PAC as their flocculant? And most of the time, it's trickle-fed into the water. But does anyone ever measure it? This is one of the things they came across. We trust it's there, but we never actually measure it's there. So there was talk about, should we start doing aluminium testing? It's just a thought. It's just something that we may want to do as an update for our water testing. Regular aluminium testing to prove that your PAC system's working and to prove what you're being sold as polyaluminium chloride actually is, because a lot of it's done on trust. So briefly, 30 years of SPATEX. I don't know if you noticed, they've pushed it a bit, that it's their 30th anniversary, and it's my 20th show. My first one I was 21, a few years ago in Brighton. I wasn't really, but... so these are the sort of talks I've done in 20 years of presentations. And we also once did a live water testing demonstration and workshop. The kiddos did it once. It was a bit of a challenge. Yeah. I'm going to look at some of them. The first talk I ever did was photometers and comparators. Which one is best for you? Photometers are easy to use. They're accurate. They're versatile. They do lots of tests, but they can go wrong. That's the thing. Comparators are accurate and versatile. They're reliable. They can't go wrong. They're not going to pick up until they've got a software error or a battery's run out. They are easy to use, but they are subjective. So they're not suitable for everyone. If you're colourblind, you can't use them. So the conclusion I came up with in 2008 is, it's up to you which one's best for you. They've both got so you have to decide. I did a talk on water testing through the years and history of swimming pools. I think this was might have been on the 20th anniversary of SPATEX. That's the first ever known swimming pool in 2500 BC in Pakistan, or 2600 BC. Basically, the history of water testing is a bit sketchy. Their water testing was done in the early parts of the 20th century, but it was based on traditional chemistry, and you were looking at standards and putting things side by side, and it was a bit hit and miss, to be perfectly honest. This was a 1953 chlorine test based on a comparator using orthotoluidine. You had to make your own solutions up, put in some orthotoluidine. Anyone know what orthotoluidine is? It's very good at testing for chlorine. It's also very good at killing people, and it's been banned now, so it didn't really last very long. So it was a very good test, but yeah, that's what they looked like. And you would use 0.5 mil of each in a 10 mil of pool water. So the basis of what we do today. And then DPD was discovered by Tom Palin in late mid-50s. The concept of tablet chemistry was born. In the early 60s, tintometer and Palin test worked together to form the first chlorine disc. It became the standard test method. The number of the discs grew, the number of tests grew. Photometers were introduced in the 1980s, and that's an early comparator kit. So it was the only thing you notice there is all the tablets were in bottles and not in foils. But basically, since 1980s, nothing's changed. It's still DPD tablets. Photometers have developed and changed, and et cetera, but the concept and the basis of testing has remained the same. And last year I did this talk on, can a good water testing regime save you money? And the conclusion was yes, because it can help you control chemicals, prevent issues, help look after the plant, reduce possible downtime, reduce servicing needs, costs, and lower wastage. And the example I gave is you're running a pool, and one morning you come down to this, or maybe this, and you think, oh, that don't look good. So you have to do this. You have to get someone out. You have to close the pool. You have to check the chemicals, you have to clean the pool, you have to waste the water. You're basically wasting lots of money, lots of heat, lots of energy. So having a good testing regime can save you money. And talk about testing regimes. If you're running a commercial pool, you have to have a written one. You have to say what the ranges are. You have to say when and how often it will be tested. You have to say what corrective actions there are. You have to say when it will be closed, and you have to log the results and keep them for 5 to 7 years, I think it is. So you need to have a good testing regime. And doing the test is only part of it, as always remember. Read, record, react. So read the results, record the results. Someone should be able to react to them. And that's it. Thanks for coming. We are, if you want to come and see us, on stand E16. That's me, if you didn't agree. We've got our new photometer on show. It does 13 tests in a handheld unit for the first time. You'll be surprised to hear that 3 of those tests are sulfate, phosphate and aluminium, plus some other tests. And, this is the exciting bit, you could get a chance to win a very exclusive Lovibond teddy bear. There's only 2 made. They are really that exclusive. But yeah, we have a competition to win a Lovibond teddy bear, and you can win it on the spot. So it's not one of these things where we send it to you once we've got it made. It's actually there. Yep, that's me. Thanks for your time.